Welcome back, guys. Okay, once again, we need to take this opportunity, liberty, to make the show possible. Thank you so much for it. I mean, what an incredible way to prepare us for the final exams. Okay, do me a favor, on your smartphone, download the Tenfold Education app. Lots of goodies on there, a lot of study material that will definitely help you. And lastly, please, Matrics grade 12s, go to YouTube, right? Go and click on the Mindset Learn, right? Give us a thumbs up and enjoy the content that's on there. Okay. So we've been discussing questions that I do find that the students do struggle with. Okay. And now we're going back, right? I always tell my learners 2 steps back, 1 step forward, right? In this case, we're going back to the fundamentals of geography, especially with climate. Okay, because we need to discuss it and to be able to understand some of the topics that we are doing, that you get your basics correct. And I just want to have a look back at pressure. Okay, now what I've done here, I've got a diagram that represents low pressure and high pressure. Okay, now very importantly, we're dealing with low pressure systems in South Africa, the interior, in summer. Now we know a low pressure is rising air. It's warm air that rises. Okay. In order for it to be able to rise, it needs to be forced to rise, or it's been created by warm conditions. Okay. And then we have high pressure systems. Okay. When we look at high pressure systems, we know it's sinking air. Okay. Subsidence taking place. The reason might be because of colder conditions, right? Or the air is being forced to rise. Now, most importantly, grade 12s, right? If we look at South Africa, and I'm just going to use these diagrams, right? Here you can see the latitudinal position. It's the 30-degree latitude position, and we are dominated by the subtropical high pressure belt. Okay, and I'm just going to write it down here. So we are dominated by a high pressure belt because when we look at the primary circulation of air, right, we have convergence in the upper atmosphere and it causes the air to sink, creating the subtropical high pressure belt. Now we need to get our basics correct. Okay, low pressure system in the southern hemisphere has got a clockwise rotation. Okay, high pressure system, anti-clockwise circulation in the southern hemisphere. So I'm just going to fill it in here. Anti-clockwise, clockwise. Okay, there's our low pressure, clockwise circulation. Okay. Now, just by discussing these 2 diagrams, how do I know that A represents summer and B represents winter? This is the basics, grade 12, and I promise you if you get this correct, right, you understand these concepts, the rest of the content will be much easier to be able to understand. Now, first and foremost, we experience a low pressure during summer because we experience warm temperatures during the interior. Okay. Before I move to the winter situation over here, now remember, we are surrounded by high pressure systems. Over here, we have the South Indian high pressure system. And over here we have the South Atlantic high pressure system. Anti-clockwise circulation, as you can see. Okay. Now, what makes our climate so significant is a bunch of factors, and you studied this in grade 10. Factors that influence South Africa's climate. Okay, it's altitude, distance from the sea, and ocean currents. Okay. The ocean currents plays a vital role in southern Africa's climate because we are surrounded with 2 different ocean currents. We have the warm Mozambican current flowing on the eastern side of southern Africa, and we have the cold Benguela current flowing on the western side. Now, the reason why we experience this low pressure system over the interior is because of insulation. We experience warmer conditions, right, the interior warms up and the air rises and it can cool, condense and clouds. Okay, very importantly, now you're probably sitting at home and wondering, okay, but hang on, we're talking about winter over here and where's the Kalahari high pressure system? Okay, because we are situated in the subtropical high pressure belt. 100% correct, but like I've mentioned to you just before the break, the Kalahari is extremely weak during the winter, during the summer, apologies. Okay, why? Because of warmer temperatures, because of the season. Okay, so it's still there, but very weak subsidence. Okay, so it allows low pressure systems to develop over the interior. Okay, going back to this basics to explain it to you. This South Indian high pressure system, right? And very importantly, you need to have a look at that, right? What is wind? So when air moves from a high pressure to a low pressure. Okay. Because of this low pressure over the interior in South Africa, and because of the South Indian high pressure, it's situated over the Indian Ocean. We've got the warm Mozambican current. It allows for warm, moist air flowing to the interior of Southern Africa. Okay. Now, obviously, as you can see, it's a high pressure to a low pressure. Now, because of its high pressure system and because of the warm Mozambican current, it allows warm, moist air to reach the interior of Southern Africa. And that's the reason, I'm just going to draw cumulonimbus clouds over here, we experience rainfall over the interior of Southern Africa and the East Coast during summer. Okay, cumulonimbus clouds, it's warm, moist air. We have a low pressure over the interior, right? We have warm, moist air coming in from the South Indian high pressure system because it moves over the warm Mozambican current. It allows this moist air to reach the interior. We have the low pressure over us, right? The air rises, it cools, condense, clouds, and the possibility of rain. Okay, but when we move to winter, now as you can see, winter immediately we can see and we can identify that is the Kalahari high pressure system. It's present over. Now before we discuss it, right, strong subsidence of air. So the South Indian high pressure system is still here. Okay, the South Atlantic high pressure system is still situated over there. Please take note, right, that these high pressure systems do migrate during summer and winter. Okay, during summer, the South Atlantic and the South Indian high pressure migrate towards the south. Because what happens, in grade 11 you've learned about it, the ITCZ, Intertropical Conversion Zone, moves south of the equator. So this pressure belt shifts down southwards. Okay, that's another reason why we don't experience mid-latitude cyclones in summer, because this South Atlantic high pressure system blocks them out. Okay, because they migrate further south. But during winter, what happens? The South Atlantic high pressure and the South Indian high pressure, they migrate north. Right? Because the ITCZ, Intertropical Conversion Zone, migrates north of the equator because the northern hemisphere experience summer conditions. Now, if you look at winter, we have the Kalahari high pressure present, right? It's sinking air, strong subsidence. Okay. So that meaning is that no air can rise, right? So we can't have that effect of the air rises, consists of a lot of moisture, right? It cools, condenses, clouds, and rain. Now, if you live in the interior in South Africa, you will find that mostly, the majority of our days during winter is beautiful, dry, sunny skies. The simple reason is because there's no warm, moist air that's being allowed to rise over the escarpment onto the interior. Okay, that's the basics. And the question is going to come up with the Kalahari high pressure, right? The impact it has, especially during winter on us. And what's the difference? What happens during summer and winter? The difference between them. Attached to there's a couple of questions that we can quickly answer. Okay. The first one, right? Name the pressure cell that dominates the land in this season represented by map B. Okay, and we've done it, and I've explained it to you. It's the Kalahari high pressure system. Okay. Then, state two characteristics of this pressure cell. Now, if you already discussed it, we know. Okay. Right? Strong subsidence. Oops. Right? Situated over the interior. And we've mentioned as well, it shrinks during summer. And it dominates the air movement over the interior. And I'm quickly going to explain it to you. How does it dominate the air movement over the interior? Okay. Now I'm just going to draw two cross sections. Okay. This is summer. This is winter. Now, these couple of pointers that I just mentioned, right? We say that the Kalahari, it shrinks during summer. It's weak. Okay. So what happens is it causes the inversion to be above the escarpment. Here's the escarpment. And we discussed earlier that the South Atlantic Indian high pressure allows warm, moist air to reach the interior. Now, as you can see, this warm, moist air can travel from the coast over the escarpment onto the plateau. Okay, what else do we know? We know we have a low pressure system because it's summer, warm temperatures. The air is going to rise. So what happens with this warm, moist air? Travels up to the escarpment, it cools, it condenses, it clouds, and gives the possibility of rain. But now during winter, like we've mentioned, the Kalahari is high pressure is much stronger because of colder temperatures. So we have strong subsidence taking place. Right, and I'm going to write it there. As you can see, because of a strong subsidence, it causes the inversion to be below the escarpment. So what happens now? All that moist air that comes in from the South Indian high pressure can't rise further than the escarpment, creating clear blue skies over the interior. Okay. Now that is the Kalahari high pressure, how it dominates and determine the weather conditions over the interior of Southern Africa. Okay, unfortunately this is all we got time for today. Thank you for joining. I'll see you next time. Ciao.